Welcome to lesson 86. We are flying through, and this lesson I will go ahead and tell you you're going to need to buckle your seatbelts. Put your thinking caps on, and you're going to be okay. You're going to be fine, but this is not an easy lesson. And so I'm just going to tell you that off the top. Those of you that are the overachievers, you're going to go, I don't know what she's talking about because this is awesome and fun and I love this and it wasn't hard at all. But I will also tell you this is one of my favorite things to do in Algebra 1. And yeah, my son said I'm a monster. So yes, I am a monster nerd and I love long division of polynomials. So we're going to start out with an easier one. But I'm also going to tell you that this is lesson 49 in the inverse process of it. It says that we found out the product of two polynomials. Now we're going to learn the inverse process. So it's kind of like this, but it's not always just two polynomials. This could be a polynomial and a binomial and a trinomial, which is, yes, product of two. Okay, I see what they're saying. Polynomials, not just binomials. So this isn't FOIL and unfoiling. This is more complicated. And believe it or not, in the past, I have helped students in college math with these types of problems. So you will see these again if you are moving onward to higher math. And for some of you, if you don't understand it now, I need you to figure it out now. I need you to ask the questions, do the practice, do it now. Don't let it become the bane of your existence, which I hope it won't be. Okay, we're going to do an easy one first. We are going to divide this trinomial by x. Well, we could just say it's like factoring out an x. Yes, it is. You're right. It's just like factoring out an x. So it would be like saying this divided by x, this divided by x, and this divided by x. So we could do this like what we've done before, factor it out, or we can start the process with long division. Now, let me go back to 3rd and 4th grade math. I think it may even be earlier than that. I'm not sure. But let's go and say, okay, 2 goes into, let's say, 123. Let's do it that way, okay? So in regular long division, like you did back in elementary school, we would say 123 divided by 2, and then 2 would not be able to go into the 1, and so we would have to say 2 goes into 12, and so we would say it goes in 6 times, and then we would say 6 times 2 is 12, and then we would subtract, and that becomes a 0. It should always become a 0 unless you have a remainder that gets added to the next one. So sorry about that. It shouldn't always become 0. It should definitely become the next step here. 6 times 2 is 12, and then you're going to have subtracting. You're going to bring down. If you have a remainder here, it gets put with the 3, and right here we don't. So it's 2 into 3. 2 goes into 3 one time. 1 times 2 is 2. We subtract, and we have 1 as our remainder. If you remember from about 5th or 6th grade, you realize that you didn't put R1 anymore. You made it a fraction. So that would be your answer. We're going to do that same process. Same process. Don't let all the letters scare you. It's going to be the same process, and it's going to be okay. So I'm going to put 3x cubed plus 7x squared minus x inside the long division, and x is going to be on the outside. So I'm going to say x goes into 3x cubed. How many times? What times x gives you 3x cubed? Well, we already know it would be 3x squared. So then we take this times this and put it under here. And it's the same process. So now I'm going to say 3x squared times x, and then I'm going to write that right underneath this first term. 3x squared times x is 3x cubed. Now, remember when I goofed and I said this should always be a 0 here? It's not always going to be a 0 when you're doing long division here. But when you do it here with polynomials, it needs to go away. It needs to be the whatever it's going to take for that first term to go away. So that's where it does connect It's just a little bit different in the process. Once you do this over and over, and that's what it's going to take, lots of practice. So please, please practice this. Don't try to cut corners. Do this the same way as you would do division of multiple digits. So it's going to, like I said, it's going to be just fine. This is going to cancel out. 3x cubed minus 3x cubed becomes 0. I'm going to bring down the next term. That becomes 0. I bring down the next term. 7x squared. Now I'm going to do the same process. X goes into 7x squared, 7x times, because 7x squared divided by x becomes 7x. Now I'm going to multiply 7x times x, and I'm going to get, I put the minus sign there a little bit too early. I'm going to get 7x squared, and then I subtract. Later on, you're going to need to remember that it's super important to subtract. We're going to change signs and all that kind of stuff. But that one's going to go away, and that's what we want each time. We want a term to go away. Now we have one more thing. We're bringing down the negative x. What times x gives you negative x? And that would be negative 1. So negative 1 times x is negative x. Now when I subtract, I change the signs, because a negative minus a minus, which you could say subtracting a negative, becomes a positive. So what I do is I go ahead and write the negative sign over here, but then I change my signs in here, just so that I know that I did it. It's up to you how you want to do it, but that's how I do it. So then I've got negative, positive, there's my 0. I don't have any remainder. So this here is my answer. 3x squared plus 7x minus 1. You don't have to rewrite it. You can just circle it in your work like that. If I were to multiply this number times this number, I would get this inside here. And you can always check those. That's the nice thing. It might take a little while, but you can do it. Now, we're going to get a little bit more complicated. This is still only a monomial, which is helpful. And so our 12x squared, or x to the 12th minus 8x to the 8th plus 4x to the 6th, all divided by 4x to the 4th. So same process. Just remember long division. Same process. This goes into this. How many times? It's going to go 3x to the 8th times. Because when I multiply this times this, 3x to the 8th times 4x to the 4th, I'm going to get 12x to the 12th. And remember, I want those to go away when I subtract, and they do. I don't usually write the 0. I just cross it out. It's up to you however you want to do it. You just want to make sure that it cancels out. Bring down the negative 8x to the 8th. 4x to the 4th times what gives you negative 8x to the 8th? Well, that would be negative 2x to the 4th. And when I multiply negative 2x to the 4th times 4x to the 4th, I get negative 8x to the 8th. And so then I do that thing again with my subtracting. Up here, I did that subtraction sign. That may still confuse people. It's really a personal thing. I don't know. It's gonna take how you do best. I do my little subtraction sign over there, and then I make this sign changed, and that makes that a 0. That makes it go away. But don't say it's negative 8 minus positive 8, because it isn't. We already changed the sign. We already applied the negative to it. It's negative 8 minus a negative 8, and that's why it becomes plus. So just so that you know, that negative sign over there is done once you change the signs. Okay, so onward. 4x to the 6th. What times 4x to the 4th gives you 4x to the 6th? That would be x squared. X squared times 4x to the 4th is 4x to the 6th. I subtract, and I have 0. No remainder. This is my answer right here. Hopefully these are quite straightforward for you. No difficulties. But if you do have questions, make sure you ask. Make sure you look at your book. You can also look at lesson 86 in your book and hopefully get some tips and tricks for that as well. The main thing is to remember it's just like long division in the process. All right, now we're going to level up. We're going to divide this by a binomial, negative 3 plus x. So I'm going to set it up the same way. Negative 2x squared plus 3x cubed plus 5x plus 50. You're going to need lots of space to do these problems. I'm going to take the first term here and make it go into here. But I look at it already and I go, that's not going to work, because you always have to have it in descending order of the variable. Because if you looked at that and you said -3 times nothing, I mean, there's nothing that I can do easily that'll end up with -2. Well, that'll give you an indication that you're doing it wrong. This needs to be switched around. When I switch these around, and I've noticed some of you have been getting these incorrect on your assignments, when you switch these around, you have to take the sign that's right in front of it. So the sign that's right in front of the x is positive. So I can switch these around, but this negative stays here. It's not -x plus 3. It's x minus 3. So I'm going to put x minus 3. Now I look at this and I think, oh wait, there is my x cubed. That should be over here. So you see how that works? Always remember descending order of the variable before you even write this out. So now I'm going to have to go back and erase this. I'm already showing you what you're going to run up across in your process here. Make sure it's x to the third, x to the second, x, and then a number. If it goes straight from an x to the x squared to a number and there isn't a 3, 2, 1, 0 type thing, you're going to want to have a space for that, but we have another lesson that we'll be doing that with. So I'll show you that later, but you may see that coming up, and it's okay. We're going to level up again. Here we go. X goes into 3x to the third. How many times? It would be 3x squared. So now 3x squared times x, this is just like we did before, 3x to the third. The difference is that we have another term here. So we're going to take 3x squared times this as well. So we did it times that, the x, and now we're going to take it times the -3. 3x squared minus, times -3, multiply. 3 times -3 is -9. X squared times 1 is x squared. You want to make sure these are like terms because that's where you're going to line them up. Now we're going to go to that subtraction part that we did on the front page. This is where it comes in handy. When you put a minus sign here and you change the sign there, you're done. You've subtracted. Or in algebra, we say algebraically adding. Okay, 3x squared, x cubed minus 3x cubed is 0. That's why you want that. You definitely want the first one to be 0. -2x squared plus 9x squared. They are like terms, and I end up with 7x squared. Now that's my new term. Now I go to my next step. I'm going to erase these, arrows so that they don't get confusing. Now I'm going to take this x. What times x gives me 7x squared? And that would be 7x. 7x times x gives me 7x squared. 7x times -3 gives me -21x. Okay? Now, I need to bring down this 5x because I'm going to be doing these, combining these like terms. I'm going to subtract. That's my next step. Subtract. So I put a minus sign there and I change that to plus. Very, very important. 7x squared minus 7x squared, 0. 5x plus 21x, I get 26x. I'm going to bring down the 50. And now x times what gives me 26x? Well, that would be 26. 26 times x is 26x. 26 times -3, is 78. And so you could go over here if you needed to. Remember, just do your work wherever. That's good. I like to see it. And this is a it's a negative right now. You see that? Negative 26 times -3. Now I'm going to subtract, and that's where it changes. So this becomes a 0. 50 plus 78 is 128. I can't divide 128 by x. So this is my remainder. I'm not going to just put R128 like in 4th grade. I'm going to make it a fraction. So I'm going to put plus, and then I'm going to take my remainder, 128, and put it over the divisor, x minus 3. Now I'm done. This is my answer. Some of you may say this is pretty messy. It is. You could rewrite it. That's fine. Or you can just circle it. I will find it. I'm used to this. It's really okay. And here I'm going to run out of space because of the paper punch. So it's really okay. I can read amazingly well. Weird handwriting. Main thing is that you understand the process and then you just keep on doing the process. Some of you are going to try to cut corners and it's going to fail terribly, and I don't want you to do that. Don't cut corners. Do it the right way. Okay, example number 4. I already saw that pitfall of arranging it in numerical order by descending order of the variable, so that's what I'm going to do before I even start writing. I'm going to write this in descending order of the variable. So my 2x to the third is the largest x in degree. My next one will be x squared, and I'm going to take this negative with it because whatever the sign is before the term, that's the sign of the term. So it's got to come here with it. It travels with it. Then I have negative x, and then I don't have a number. And so I'm going to show you that I'm going to put plus 0 right here because that's going to keep that place and I'm going to need it. And as you go along, that's going to be, oh wait, no. Silly. I already told you that's happening in another lesson. There's a 4 right there. I just didn't see it. So there we go. The 4 is right there. Sorry about that. Okay, now here my x goes first. It's a positive x and a negative 2, x minus 2. Now I'm going to divide like I have been. Remember, just use the same process. X goes into 2x cubed. How many times? What times x gives you 2x cubed? It would be a 2x squared. Now I'm going to take this here times both of these terms and write them under here. 2x squared times x, 2x cubed. Remember, you always want that first one to cancel out. 2x squared times negative 2 is negative 4. Whoops. Negative 4x squared. Now the next step is to subtract. Negative, positive. Change the signs. This should always be 0. Negative 1, because any variable by itself has an invisible 1 in front of it. Negative 1 plus 4 is 3x squared, and I'm going to bring down the next term. X times what gives you 3x squared? It would be a plus 3x. 3x times x, 3x squared. 3x times negative 2 is negative 6x. And then I subtract. Same process. Minus, plus. I go ahead and change the signs. I've got those cancel out. That's how it should be. Negative 1 plus 6 is positive 5. And then I'm going to bring down my 4. What times x gives me 5x? That's 5. 5 times x, 5x. 5 times negative 2 is negative 10. Subtract, minus, plus. Same process, 0. 4 plus 10 is 14. That's a remainder. That goes up here over my divisor. So I have plus 14 over x minus 2, and that's my answer. So once you get it, this is a very straightforward process. It happens this way all the time. I already gave you a little heads up on what happens when there's a missing term and we put a 0 there. Don't fast forward through this lesson, please. I'm telling you, if you fast forwarded, please go back, do it again, make sure you know how to do this. You have an assignment that has quite a few of these. You will see these for the rest of the school year. And heads up, you're going to see this a lot in Algebra 2. So just get ready to do this. And some of you, I know, that will hate it right now are going to love it later because it's something that once you do it, it's just done the same way. It's an easy answer. And so it's always nice to get to a problem where I already know how to do this. This is awesome. So plug along, push through. You've got this. I have confidence in you. Long division of polynomials. You got this. See you later. Bye.